So on to number 4 from Standard FIF B4. This is the review for rational equations and functions. So we're asked to do two things. Identify all vertical asymptotes and holes in the function. So I'm going to start by taking the numerator over here, and I'm going to factor it if possible. So I see that all three terms have an x. I'm going to factor out an x. And I'd be left with a trinomial x squared plus 5x plus 6 inside. And I know this trinomial factors into x plus 2 and x plus 3. On the opposite side, I'm going to do the same for the denominator. I can see that each one of the terms is divisible by 3. So I factor out a 3, and I can see that the trinomial inside is also factorable. So step 1, I factor out the numerator and I factor the denominator. Now I'm going to write the numerator over the denominator. All right, to identify the vertical asymptotes, and I'm going to say VA. To identify the vertical asymptotes, I look at the three sections that I see right now down below. And if one of those sections contains an x, then I can identify a vertical asymptote. So this part contains an x. So ask yourself, what's the only number that you can substitute in for x? And when you substitute in and you evaluate this portion, you'll end up with 0. So what number subtract 1 gives you 0? The answer is 1. Another way to do it is to set it equal to 0 and solve. So x equals 1 is a vertical asymptote. This section contains an x, so I can go ahead and do the same. What number plus 3 equals 0? Negative 3. This does not contain a variable, so I cannot get a vertical asymptote from this portion. So there's two vertical asymptotes. That's the first part of the problem. The second part of the problem says, are there any holes in this graph? Here's how you determine if there's a hole in the graph. X subtract 1 is a factor. Is there an x subtract 1 factor on top? Nope. X plus 3, is there an x plus 3 on top? So cancel the x plus 3 in the bottom and cancel the x plus 3 on top. Now x plus 3, what is the only number you can plug in for x and then this factor equals 0? X equals negative 3 is the whole. Okay. If we had to write it as an ordered pair, we would plug negative 3 in for x. You'd work this whole thing out and you could figure out what the y value is. If you only have to identify what the x value is for the whole, we're done. Again, if you write it as an ordered pair, you plug in negative 3 to the original problem, negative 3 wherever you see an x, and you solve it to find out the y value. Okay, part B. Same concept. So I'm going to start by taking the numerator. I'm going to factor the numerator. I can see that each one of the three terms contains an x, so I factor out an x. The trinomial inside can be factored into x subtract 4 and x subtract 1. And I look at the denominator. Again, there's an x in each one of the terms. And this factors into x plus 3 and x minus 2. Numerator on top. Denominator on the bottom. All right, so I have three groups here. This contains an x. So what makes this factor equal to 0? The number x equals 2. This contains an x. What makes this factor equal to 0? X equals -3. This contains an x. There's only one number I can plug in for x, and this equals 0, and that's the number 0. Any holes in this graph? So there's no factors of x subtract 2 on top, and there's no factors of x plus 3 on top. There is a factor of x, so these can cancel out. And what makes this portion equal to 0? 0. So again, this is just the point, x equals 0. If they ask for the actual ordered pair where the hole occurs, 0 is the x value. You go back up to the original, you'd plug in 0, and actually for this one, since they all contain an x, and if we plugged in a 0 for each, we know that we'd also get 0. Moving on to part C of number 4, part C of number 4. All right, so the numerator, they both contain an x, but I see the most amount of x's I can factor out of both is 2. So 3x squared, and it left inside would be x subtract 4. On the bottom, you can factor out an x and be left with x squared subtract 6x plus 8. Cannot do anything more with this. The only thing I may do is I may write this x squared as x times x. And that will make sense in a little while why I did that. It's not necessary, but it may help you initially when you're learning about this. This trinomial factors into x minus 4 and x minus 2. Writing the numerator on top and the denominator on the bottom. Vertical asymptote. What makes this equal to 0? 2. What makes this equal to 0? 4. What makes this factor equal to 0? 0. Now, can anything be canceled out? There's not a factor of x subtract 2 on top, so I can't do that. There is a factor of x subtract 4. What makes this factor equal to 0? X equals 4. There is an x on top and an x on the bottom that you can cancel. And again, what makes that factor equal to 0? 0. And if they asked you to find not just the x value where there's a hole, if they asked you to actually write the ordered pair, you would plug 4 into the original problem solved to get a number, or you'd plug in 0 into the original to solve to get an answer for y.